Okay, so today we are talking about P3. We are going to start graphing some basic equations and how we go about doing that. First of all, let's talk about an equation in two variables. Basically, it's just a description of a relationship between two quantities. So an example of that would be y equals 3x minus 4. So this is an equation in two variables. It's a relationship between x and y. Right, so an ordered pair in xy is a solution to an equation in x and y. And so basically an ordered pair is just a set of numbers that makes the statement true. So for instance, if I look at the ordered pair 2, 2, so again, x is always first, y is the second coordinate. If I check this out and I put this into my function here, I have 2 for y is equal to 3 times 2 minus 4. And since this is 6 minus 4 over here, this makes this a true statement. So that means that 2, 2 is a solution to the equation y equals 3x minus 4. So it's an ordered pair that makes the statement true. Also, if I look at 3, 5, so if I plug in 3 for x, I should get out 5 for y. So using the same equation, I have 5 is equal to 3 times 3 minus 4. And so this is 9 minus 4. So again, this works out. These are both solutions to my equation. So let's look at a different equation here. So let's look at y is equal to x squared plus 1. And let's look at the ordered pairs 3, 8 and 4, 17. We want to know, are these solutions? Okay. So let's try out 3, 8 first. So if I plug in 8 for y and 3 for x, so I have 8 equals 3 squared plus 1. And 3 squared plus 1 is actually 10, so these are not equal. So this is not a solution. All right, so I'll try out 4 and 17. If I do that, I have 17 is equal to 4 squared plus 1. And this is equal because 4 squared is 16 plus 1 is 17. So 417 is a solution. So 417 works. It is a solution. 3, 8 is an ordered pair. It just is not a solution to our equation. All right, so let's talk about how we go about graphing these. Now, there's lots of reasons that we like to graph. It makes things a lot easier to understand when we're looking at a picture of something. So graphing basically means we're going to take a group of these ordered pairs and then plot them. Okay. So first of all, let's just walk through in words how we go about graphing. So this is the standard form. Now we're going to learn more interesting ways to graph. So you have to be really careful when you're graphing using the point plotting method. So because you can sometimes misinterpret things if you don't plot enough points. So what we usually do when we're plotting to graph, so first we rewrite the equation so that one variable is isolated on one side. Now the two equations that we just looked at, the y equals 3x minus 4 and the y equals x squared plus 1, right, they both already had that going for it. They already had y equals. Now normally we use y equals, but it's not wrong to solve for x if x is easier to solve for. But it's a little bit easier if you have one of the variables isolated on one term. That way you just plug in the other number and then you get out that number. So the second thing that you want to do is to make a table showing several solution points. So you need to figure out several different ordered pairs that work for it. And in most cases, you can choose your own values that you want to plug in and figure out which ones they are based upon the numbers in your graph. And then the next part is you just take those values and you put them on an ordered, right, the Cartesian coordinate system you plot all your ordered pairs, and then you connect the points with a smooth line or curve. So we're going to walk through this procedure with two different equations here. And really, number 1 is going to be done for us in both cases because both of my equations are already isolated. Okay, so I have this all set up and ready for us to go. And so we're going to graph first this y equals 2x minus 1. Now I have chosen x values for us. Usually I'm going to choose small numbers around it, and I definitely want to choose both positive and negative numbers to make sure that I have enough solutions points to make sure that I have a good clear understanding of what my graph should look like. Now later on we're going to figure, when we talk about different types of functions, we'll have more of an understanding of what these graphs look like, so we don't really have to plot that many points. But for right now, since we don't really know anything about them, we're going to make sure that we plot enough points to make the shape of the graph clear. So I have chosen values of x. Now the reason I choose to plug in values of x is because it's a lot easier to pop in values of x and I'm immediately going to get y from a simple calculation. I could also, I could have instead chosen to put in values for y. It's just going to take me an extra step to solve each one of them. So this is just the easiest way around it right now. So for each one of these, I'm just going to take these numbers and put them in here to figure out what the matching y is. So when I plug in negative 2, I get 2 times negative 2, which is negative 4, minus 1 more gives me negative 5. I'm just going to fill in my chart right now. If I plug in negative 1 in for my x again, 2 times negative 1 is negative 2, minus 1 gives me negative 3. If I plug in 0, then I have 2 times 0, which is 0, minus 1. So 0 minus 1 is negative 1. I plug in x is 1, and I get 2 times 1, which is 2, minus 1 gives me 1. And then I plug in 2 as my last one. 2 times 2 is 4, minus 1 is 3. Oops, I've got them a little bit off, but they're at the end. So now I'm going to plot each one of these. Okay, so again, x is the directed distance from the y-axis, and y is the directed distance from the x-axis. So when I plot negative 2, negative 5, that means I'm going to go in to the left for x. So there's negative 2, and then I'm going to go down here to negative 5. So here's my first point. So that's negative 2, negative 5. Negative 1, negative 3 is about here. I have 0, negative 1. Let's see, that would be here. I have 1, 1, approximately here. 1 to the right, 1 up, and 2, 3, approximately right here. And so my steps tells me, okay, so I isolated my variable. I didn't need to do anything there. I made a table. I plotted them. And then the last thing is just to make a smooth curve or line. This is a line. It's hard to draw a straight line. There we go. It looks approximately like this. Now it should be a perfectly straight line, and I probably should have used Desmos here, but I thought maybe for this one this would be a little bit easier. So this is what y equals 2x minus 1. Now I put these little arrows on here, right, because I can kind of see that there's going to be a whole lot of points that are going to satisfy this, right? I could keep going both in both the positive and negative values here. So I put the arrows on to say that there's a lot more solutions and they should be on this line. All right, so let's look at a different graph. And that is x squared plus 1. Again, I just have the basic numbers filled in. I just want a couple points on each one so I get a good idea of what this graph is going to look like. So here I plug in negative 2. So I'm going to plug in negative 2. If this isn't given, right, you can choose values for x yourself and you just figure out what the matching y is. So I plug in negative 2 here. I have negative 2 quantity squared, which means negative 2 times negative 2, which is 4. And then I add 1, and so this is going to give me 5. I plug in negative 1. I'm going to get negative 1 quantity squared, which gives me positive 1, and then plus 1 gives me 2. I plug in 0, and then I have 0 plus 1, which is 1. I plug in 1. 1 squared is 1, plus 1 gives me 2. And when I plug in 2, I have 4 plus 1, which is 5. So I have these points here. All right, so let's graph those. So, oops, I didn't finish my labeling. -2, +5, so I'm going to the left and then up here. I have -1, 2 here, 0, 1 here, 1, 2 here. Again, if you need help plotting points, then you need to go back and watch the plot pointing or the point plot basics. I have another lecture online. Okay, so I'm just going to connect these then with a smooth curve. Okay, so this one up here, this was a line, right? This one here has a special name as well. It is called a quadratic. We've solved quadratic, or we've at least solved some quadratics. The graph is actually called a parabola, right? This one is actually linear and is a line. This one is the type of function is a quadratic and the graph is a parabola, this U shape here. All right, so this is just the basics on graphing. Now there are some issues with graphing, and so you need to be sure that you're plotting enough points, because sometimes if you don't plot enough points, then maybe you're not going to understand that what the complete graph looks like. For instance, for my parabola, had I not graphed these negative ones, I may have thought that maybe I had some slight curve and maybe it came down here, or maybe it really kind of looked more like a line. So when you're plotting points and graphing, you have to be more careful. We're going to learn more exact ways to graph later on in the class. All right, so the last thing that I want to talk about today is finding intercepts. Okay, so in my beginning video, I talked about x and y intercepts. Okay, so just to reiterate, an x-intercept is a point that is sitting on the x-axis. And what's special about it is if it's sitting on the x-axis, it always has a y-coordinate of 0. I mean, if I just draw a little picture here, right, and this is my x and y, then when I draw my x-intercepts, right, they're sitting on x. And so if I think about the coordinates, the ordered pairs that go with these points, what they have in common is the fact that y always has to be 0, because if it's sitting on x, then I didn't move my graph up or down, or my point up or down. And so the same idea is with the y-intercepts. If I put y-intercepts on them, right, they're sitting on the y-axis, and what's true about them is that the x-coordinate has to be 0, because if it wasn't 0, it would either be to the right or left of the y-axis. So we do a lot of finding intercepts in this course, and that's because a lot of times when we're graphing, it makes it really nice to graph things using our intercepts, and they are also important later on when we're finding solutions to polynomial equations as well. So we're going to just find the x and y intercepts for both of these equations. So let's start with our simple one here on the left. And so I want to find first my x-intercept. So I want to use this idea. I know that if I'm looking for my x-intercept, it has a y-coordinate of 0. So that's how I find my x-intercept, is I actually plug in y equals 0 and I figure out where that is. So if y is equal to 0, what does x need to be? So I just need to solve for x. I add 4 to both sides. I get 4 is equal to 3x. And my last piece, I divide by 3, and I get x equals 4/3. So x equals 4/3 is my x-intercept. I could write it as an ordered pair as 4/3, comma, 0. While we're here, let's find the y-intercept. So the y-intercept, right, has an x-coordinate that is 0. It always has to be 0 or else it won't be on the y-axis. So I plug in y equals 0, or I plug in x equals 0, I'm sorry, this time. And so this time I have y is equal to 3 times 0 minus 4. So I end up with -4 as my y value. So that means I have a y-intercept of 0, -4. All right, so let's look at this quadratic equation and see if we can find the x and y intercepts. So we have, let's see, which one is easier first? How about if we find the y-intercept first this time? So the y-intercept means that my x-coordinate will be 0, and so I'm looking for, I have 0 squared minus 0 minus 12, and that gives me my y-intercept of negative 12. So my ordered pair then is 0, negative 12. Right? Whenever I have a y-intercept, I always have a number for my y, right, and a 0 for x. All right, so let's find our x-intercept. And actually, in this particular one, it looks like I'm going to find two x-intercepts. So this time I plug in y as 0. I have a standard quadratic, which looks like it will factor. So I factor this as x minus 4, x plus 3 equals 0. If you need help with factoring, go back and watch the lecture on factoring again. So then I have x equals 4 as one solution and x equals negative 3 for the other solution. That's me setting x minus 4 equals 0. I'm kind of skipping a step writing down here, and x plus 3 equals 0 gives me x equals negative 3 when I solve that. So this one has two different x-intercepts, and so I can write them as ordered pairs as 4, 0 and negative 3, 0. So if I was going to graph these, then these are all points that I could put on my graph. All right, so that ends today's lecture.